Hello friends, welcome to follow up. Let's have a look at problem 496, next grid element 1. So in this video, we're going to use problem 739 to solve this problem. So the technique is nothing but monotonic stack. So our goal is to demonstrate how to analyze this problem. Actually, if you have solved quite a large number of leetcode problems, actually those problems, so practicing some can help solve the others. So here is an example. First, we're going to digest the requirement, and then we use problem 739 to solve this one. So I hope that you can first review the video for problem 739. It would be much easier than to digest or look at the video for this problem. So now let's look at the problem statement. So first, the next grid element of some element x in an array is the first grid element that is to the right of x in the same array. So this is very easy to digest. So here we are given two distinct zero-index integer arrays, nums1 and nums2, where nums1 is a subset of nums2. So actually in this problem, all integers in nums1 and nums2 are unique, right? In some sense, we can regard them as indices, as sets, but with some indices, right? Or you can regard it as dictionaries. So for each element I, each index I, it corresponds to an element nums1i, right? So we want to find the index j such that, so nums1i equals nums2j, right? And then we want to find the next grid element of in nums2j. In nums2 for nums2j, right? So if there's no next grid element, then the answer for this query will be -1. So we want to return the array answer of length nums1 length, right? Such that answer I is the next grid element as described above. So this is actually very easy to digest. So if you look at this one, 4, right? We first find 4 here, right? And then the next grid element, because there's no larger ones, so we gave -1. So if you look at 1, so here is 1, right? The next larger one will be 3, right? So we get 3. Similarly for 2, so 2 is the last element in nums2, right? So there's no right element, so we corresponding to -1, right? So this is the example 1. So you can digest example 2. For example 2, you have here, right? And then you have 3. 3 is the next larger one. And then you have 4, but 4 is the last element in nums2. You get -1, right? So this is the two examples. Now let's look at the constraints. First, nums1 length is no larger than nums2 length, but this is bounded above by 1000. In other words, it's not a very large size problem. So this is the range of the elements. And all integers in nums1 and nums2 are unique, right? So this actually is very easy to check some elements, right? So even nums2 is not unique, it's still easy, right? So you can still use dictionary to, for example, you can use a dictionary to record the element and their corresponding indices. If there are multiple occurrences for an element, so you just need to record the first occurrence indices for all the elements, right? So all the integers of nums1 also appear in nums2. We have already known that, right? So here is, can you find this time complexity solution, right? So with that said, let's quickly recall this problem. For this problem, basically it can be formulated, in other words, problem 739. So given an array, so you want to find the next larger element, right? So basically problem 739 is something like this. You can give say corresponding to nums2, right? It gives a nums2 array, right? So you get 1, 3, 4, 2. Then you want to find the next larger element. So actually we can use this problem. We want to find how many indices to the right corresponding to the largest element, right? So for example, for this one, so we are going to have an array corresponding to, because 1, the next larger one will be 3, right? So corresponding to index 0, we have 1. Then 3, the next larger one, it would be 1. And the 4, there's no larger ones. That's we can set it to be 0 or we can set it to be -1. Similar 2, there's no larger ones. We can set it to be 0, right? And then when we do the reference, for example, if for nums1 in example 1, so you get 4, right? When you look at the 4, so 4, 1, 2. If you look at the 4, that's the initial result. So for element 4, so element as 4. So 4 corresponding to index 2, right? And j equals 2. And then, so this is for j and 2, but it corresponding to a 0. It means no large element in the right. Then we are going to append the result by 1, by -1, right? So then element equals 1, right? So 1 in this one corresponding to index 1, right? J equals 1. And then this basically says that, oh, to the right 1 unit, then you have a larger element. So the result will append this element, nums2. So because the index j, right, plus the corresponding, because here corresponding to index 1, right, corresponding to 1, and this difference is 1. So that is nums2, 2, that is 4, right? So we append 4. So the result will be -1, 4. So let's see, 1. So 1 is, oh, so 1 is corresponding to index 0, right? So here I'm making some mistake. So index 0. So 0, you know, in this corresponding to 1. So you have 0 plus 1. So that's the 1. So corresponding to 3. You have 3. And then you have element equals 2. 2 corresponding to indices 3, right? J equals 3. But in this list, let's use some names. Aux, but aux 3 equals 0. It means no larger element. So we just append result by -1. So you get -1, 3, 1. So there are 2 key points, right? Key points to use problem. First, for each index j in nums2. So we find how many indices or how many days as using the terminology in this problem. So you have a larger elements or temperature, right? Using the language in this problem. Then once you have this one, so you know how to check element indices. In other words, find those j's, right? Given y in nums1. So that's easy, right? We just use dictionary, right? So overall, for this problem, we're going to use dictionary for the ease of tracking the indices. And in order to get the next greater element, so we're going to use monotonic stack, right? So this one, monotonic stack, and this one use dictionary. So overall, so we use a dictionary or abstract data type to solve problem. And then the trick here is monotonic stack. Actually, this is a very routine. So you can actually check out our monotonic stack playlist in our channel. So now let's look at the 2 tasks, right? So first, I'm going to write a function. Let's see. Define next larger. You can imagine this array corresponding to nums2. So basically what we want to do is for each index, after how many indices or how many days will meet a larger element. So if no such element, so I'll set it to be 0. for the corresponding j. So return will be a list of the same length as array, right? So with this annotation, let's do this first. So I'm going to get this length of this array, right? Then we get a result variable. So because if no such element, we're going to set to be 0. So we use this initialization, right? Then we have a stack. So the monotonic stack. So to store indices. So we're going to maintain a monotonic, so decreasing stack actually. So now let's do the while loop. So for I in for and while, right? For I in range n. So now we check the stack, while stack, and so then we do monotonic stack condition. So basically array, if stack -1, the top element in the stack is less than the current element, that is array I, right? It means that for this indices, this I is the next great element. So then what we are going to do, we are going to do pop, right? Stack pop. Then we are going to set the corresponding, so previous I, so equals, let's see, I minus previous I. So in other words, after those number of indices or those days, you are going to meet another, you are going to meet a greater element, right? So I write in such a fashion that is to align with problem 739. You can check that video. So once you do this, after you exit this while loop, so you are going to do stack append. Why this is the correct one? You can think I equals 0, right? When I equals 0, for sure, stack is empty. So we didn't enter this while loop at all. Then because nothing has appeared, so we need to first put an indices into the stack, right? So afterwards, you just need to return the result. So here, let's do a print. Let's call this one just to larger. So for example, for this one, 1, 3, 4, 2. What we expect is for the index 0, so corresponding to 1. So the after 1 day, you get larger elements equals 1. And for index 1, this is the index 0. For index 1, you get 3. 4 is the next larger one. After 1 day, you get the larger one. For 4, there's no larger ones to the right. Similar for 0. This is what we want to get. Let's check that. You get a 1, 1, 0, right? And then we're done. So this is the main part. So next, what we want to do is, first, I'm going to get this information, right? So I'm going to say next larger. Let's see, gaps. So this is after how many days you get larger element. So that's next larger. This applies to nums2, right? And then in order to, for convenience of retrieval element, I'm going to use dictionary, right? So yi for I, y in enumerate nums2, right? So this way, for each unique element, I can get the corresponding indices. But here, due to the assumption that all elements in nums2 are unique, but even if it's not unique, we can, for each unique element, we get the first occurrence of the indices. That's also very simple. A direct for loop will do the job. But here, because uniqueness, I directly use the list dictionary comprehension, right? So with that said, we can prepare the return. Let's see, we have a result. And then we are going to do for y in nums1, right? So you have an element. So I don't care about the element index in this one, because I can easily find the j, right? So the j will be what? So j will be dy, right? And then for this index, let's see how many days we should use to get the next larger element. Let's call it delta. So the delta will be next larger gaps corresponding to this j, right? So this, if this delta is 0, in other words, no larger ones to the right. So then the result will be append -1, right? Otherwise, delta is not 0. So Then at this index, so j plus delta, we're going to have a larger element. So what we want to append is nothing but nums2. So j plus delta, right? So once this done, so we can return the result variable. So this forms a complete solution format to this problem. So let's first do a test, right? Yeah, this is positive one example. That's example 2 actually, right? So now let's also check example 1. Good, it also passes this one. Now let's look at the generic case. Yeah, it passes all the cases very fast, right? So actually you can analyze the time complexity. So and compare with this one, right? Actually we have already achieved this. So here I would comment that. So if you have difficulty in the logic or in the specific way we solve this easy problem, you can first review the video for problem 739 in my channel. And then you can try to digest the logic. And then you can also do the follow-up problem for this one. Here you see next grid element 1. So it should have a 2, right? Something like that. 2 and 3. You can check all those. And also you can check, for example, this one. This is problem 739. So with that said, I guess that's it for this video. Thank you.